So here is just a simple example of how you can calculate some of these measures of central tendency in R. So I'm going to be loading the mass package. I'm also going to be loading the psych package. If you don't have it, you could install it. So first of all is the arithmetic mean. So to calculate arithmetic mean is just your regular mean function, as you could see it here. But we have to take our vector of age from the birth weight. We are going to be using the birth weight data set. So we are using the age variable to get the mean age. So when I run this, you can see the mean age is 23. So let's 23. Let's check the birth weights. Let's know whether if that particular age is for the mother or is for the baby. So this is the mother's age in here. So the average age is arithmetic mean is 23. And the geometric mean function is what you use to get the birth weight age. So this geometric mean and the harmonic mean are from this particular psych package. So I could actually use it like this, and you can see geometric mean. So I could use it like this without loading the package. So if I run this now, I'm getting 22.6. As always, the geometric mean is lower than the arithmetic mean. So this is going to be 22.6, which is also approximately 23. Is the geometric mean. And when I load the harmonic mean, is 22.12. If you have noticed, the harmonic mean is usually lower than most of them. So it's 22.12. So these are almost close by. But you can see that if you want to actually take value, we usually take 22, and we take this, because most of them are not usually affected by extreme values. So to calculate the mode in R, you need to use the dex tool. This is the library that actually has the function to calculate the mode. R has a function called mode, but it does another thing else, and it's not used for calculating mode. You differentiate between R's base R mode and that of dex2 mode. Dex2 mode starts with a capital letter M. So when I use this on the H, you can see I have a mode of 20, and it's that is the 20 years is the mode, and it occurs 18 times. So this is the frequency, which is 18, and the years is 20. That is the mode of the mother's age. And that of the median has base R as a median function. So, and when we calculate the median, we have 23. So you can see that all these values are close to each other, and you can see the median is the closest to the mean. Now, for us to calculate the skewness, you need to install this particular library, E1071. Once you install this particular library, then you could use it to calculate. You could use the skewness function there to calculate your skewness of a particular variable. So to calculate the skewness of this age, mother's age variable now, I'm going to be using the skewness function and run this. You can see we have 0.7. And I told you earlier on that if your skewness value is high, above 0, it means that your data is positively skewed. If it is below 0, it is negatively skewed. And if it is 0, it has 0 skewness. So which means our data is positively skewed. So this is how we can perform most of these particular descriptive statistics in R.